So my name is Reagan Cole, and this is the infrared and hydrogen NMR spectroscopy for unknown samples. So first I'm going to start off with the IR spectroscopy. So the purpose of performing this is to know the different types of bonds in a molecule, so knowing the different bonds that are present in an unknown sample. So to perform this technique, first 3 drops of an unknown compound were added to the top of this machine and covered with a small black disc. Then we went to the computer and pushed collect sample and then find peaks and printed out our spectra, which is present here. Then the device was cleaned with isopropyl alcohol and a cotton swab to ensure that the next person who used the machine, it would be an accurate reading. So I had sample 51G3, so that correlated to group 3, and the options for this group were ethyl acetate, 2-butanone, and ethyl benzoate. So first are the possible peaks. So this peak was not labeled, but there's a possible higher than 3000 peak, which would correlate to an sp2CH bond. Then the peaks that were labeled. So there's 2981.78 ppm, which would correlate to an sp3CH bond. Then there was a 1713.38 ppm peak here. And I'll come back to this one, but most people would assume this would be an aldehyde, ketone, or carboxylic acid at a first glance, but I labeled that as an ester, and again, I'll come back to the reason why. Next, there's the peak at 1602.31 ppm here, and that correlated with an aromatic carbon ring. So here's group 3, the unknowns, so ethyl acetate, 2-butanone, and ethyl benzoate. So I chose the unknown sample to be ethyl benzoate because of this aromatic carbon ring that was present on the IR spectrum. Again, like I said before, I chose the 1713 to be the ester because there was an ester present here. So I just said that there could be a possible error that the ester showed up lower, closer to the carboxylic acid, ketone, or aldehyde, but in reality, it was an ester. Again, in 2-butanone, there was a ketone, so that could have shown up around the 1713, but there was no aromatic carbon ring. And then the ethyl acetate, again, there was an ester, but no aromatic carbon ring. So for all those reasons, I chose ethyl benzoate to be my unknown sample for the IR spectrum. Next is the NMR spectroscopy. So this process is a lot more rigorous and in-depth than the IR. But first, we had our NMR sample, which was in a tube, and we slid that tube into a spinner, and we left the bottom about an inch below the spinner. Then we placed that tube into an NMR tube holder and firmly pressed down until it stopped. Then we took that and placed it into the NMR hole, which would run the data for us. And then we turned the knob counterclockwise to 12 and closed the lid. Then we went to the computer and ran a whole bunch of programs, different things, so that we could find the middle of the peaks, label the peaks, and find out their ppm values. And we ended up with this NMR spectroscopy for my unknown sample. So first, there's a 7.2 ppm 1H singlet. I'll come back to this because it does seem to be a triplet, but I labeled it as a singlet, so that shows up here. Next, we have a 2.4 ppm 1H singlet here. Excuse me. And then finally, there's a 1.4 ppm, a possible 1.4 ppm singlet down below. Now, that could be a blip, but I'll come back to why that, in fact, is a peak. And then here are the NMR spectroscopy unknowns. So there are definitely a variety of them, but going back to our peaks. So for that, the 7.2 ppm value correlated with an aromatic carbon ring. The 2.4 1H singlet correlated with a benzylic group, and then the possible 1.4 ppm singlet corresponded with a saturated CH bond. So that could be a CH3, a CH2, but either way, we will see a CH in there. So first, now we go back to eliminating possible unknowns. So we know with the 7.2, there has to be an aromatic carbon ring. So that eliminates all of these molecules without one. But it also eliminates the cyclobenzene and benzene, I believe. cyclohexane and hexene. So those are these two molecules here. So now we're left with acetophenone, methylbenzate, and propylbenzene, and M-hexane here. Now, as stated, the unknown sample that I concluded it was M-hexane down below. So the reason I said it wasn't acetophenone was because it had no ketone in the NMR. So that did not show up in our NMR scan. And there would have been multiple peaks around 7 to 8, which we did not see. We only had that singular peak at 1 or 7.2. I said it was not a methylbenzate because there were no ethers in the group, and just the peaks would not correlate with what we saw in our NMR spectra. Next, I said it was not propylbenzene because here I labeled this 2H would have come up as a multiplet because there's a 3H and another 2H, and we did not see a multiplet on our spectra. And then finally, that brings us to M-hexane. So this hydrogen here would have been the 7.2, and the reason I said this was a singlet was because it's perfectly between these two hydrogens as well as these ones. So instead of saying it was a triplet, I said it was a singlet because it is perfectly symmetrical with everything around it. Next, the 2.4 ppm value would have been this singlet here, the 1H singlet, because there's a single hydrogen there, but it also has no neighbors around it, meaning that correlated with the 1H singlet that we saw on our graph, or our NMR spectra, excuse me. And then finally, the possible 1.4 saturated sp3 hydrogens would have been these, and they are singlets as well because there is no neighboring hydrogen around it. And for those reasons, I concluded that for my NMR spectra, my unknown sample was M-hexane. And then, repeating myself just one more time, I concluded that my unknown for the IR spectroscopy was ethyl benzate. Oh, and one more thing with the NMR spectroscopy. The reason we do NMR spectroscopies and run this test is so we know how the different carbons, or not the carbons, excuse me, how the different protons interact with each other. So it can tell us where they're located, how they interact, what's around them, that sort of stuff. So IR is to know the different molecules and the different bonds in that molecule, but the NMR is to know how the different protons relate to one another.